Hi everyone, we're going to start today with our problem set quiz. So if you could take out either a blank half sheet of paper or a blank full sheet of paper, everything else should be put away, including your problem set. You are going to have 5 minutes to do this question. You may use your calculator on it, so you can have that out. So basically on your desk, you should have your blank sheet of paper, your calculator, and something to write with, and nothing else. Make sure to put your name on the top of the blank sheet of paper. When you are done, you'll just raise your hand and the sub will come around and collect your blank sheet of paper. And then you can, then after the 5 minutes, we'll start today's lesson. So here's your problem. Again, you have 5 minutes from now. The subs are going to pause the video and give you 5 minutes to do this problem. All right, so all of those should be handed in at this time. So we'll go over to today's lesson. We've got our new unit packets. Our new unit is distributions. And we're actually going to skip the warm-up for today just because I'm not here to kind of lead us through the discussion. So we'll skip that warm-up, but in your planners, you can be putting day 1 homework. Note, you're not doing all of the questions on each page, specifically on page 12 and 13, because we won't be learning all of the stuff on those pages today. Some of it will be tomorrow night's homework. So only do question 1 on page 12, question 2 on page 13, and then all of page 14. So we'll start over on page 1. So what is statistics? Statistics is the science of learning from data, quantifying variability, and making sense of that data that's been collected. Data is number facts and numbers with a context. So if we go to the bottom of page 1, so a variable is anything that can vary. So a characteristic that can vary, age, height, ethnicity, leaf length, anything that could change. Variables could be quantitative or categorical. The categorical things have some type of qualitative nature. Quantitative variables, we could be counted or measured. So your height, you can measure how tall you are. Your age, we can give a number that represents that. Your blood cholesterol level, you can assign a number to that. While categorical things are things that fall into different categories. That's not a great way to define it, but think of it as different buckets. You can place all the people in different groups based on a label of like a bucket or that group. So all the people that have a certain blood type, all the people that have a certain hair color or ethnicity, you could separate into groups. So this is down at the bottom of page 2, I believe. But what we're going to do is we're going to tell which of these are quantitative and which are categorical. So we've got a question for each of these, and we would want to know, would the data that we would collect represent quantitative or categorical? And I'm just going to write Q or C for each of them. So do professors of math get paid more than professors of science? Well, to answer that question, we would have to know how much they get paid, which is represented with a number. So it can be measured with a number. So this would be quantitative. So we'll put a Q next to that one. Do women live longer than men? Well, to answer that question, we would have to know each of their ages, probably on average that they live. Their age is something that can be counted or measured with a number. So therefore, that is quantitative. What is the most common language spoken at home amongst people in South Florida? Well, answers to that question would be English, Spanish, lots of other things. So those are not things that we're measuring with a number. Those are different categories that we would place people into. So therefore, this is categorical data that we would be collecting. The length of students' feet, that's something we can measure, put a number to, so that's quantitative. Favorite sport of students? That is not something that can be measured with a number. That would be categorical. And then the last one's usually the trickiest one. What is the postal code for students at a certain middle school? Well, that would be like their zip code. Even though zip codes are numbers, really you're placed into a group based on what zip code you live in. So that would actually be categorical data. So just because your categories involve numbers doesn't mean that that is quantitative. So zip codes would be categorical because it's a label of the group. So I'm going to go through a bunch of slides just talking through things. Just flip through in your packet to keep up with those slides, and then we're going to practice some examples after I go through these few slides of notes. So there's 3 types of graphs we're going to focus on in this unit: histograms, dot plots, and box plots. So first off, the dot plot, we represent each data value with a dot, and we line them up based on the dots that represent the same thing. So here's some categorical data. So each dot represents one person that thought that subject was their favorite. We stack them on top of each other so you can quickly see which ones are the most, which ones are the least. You can use this with either categorical or quantitative data. Now, because you have to put a dot for each piece of data, it's better to use it when the data set's not that large. If you've got, say, 10,000 pieces of data, that would be a pain to put them in a dot plot. You would get stacks that would be really high. They help you display any clusters or patterns in the data. You don't need a frequency axis. The frequency axis would be like a y-axis. And the reason you don't need it is you can just count the dots to see how high they are. And again, you can use them for quantitative and categorical data. The histogram, notice on the x-axis down here, we have intervals. So we have spans of values that fall into those intervals. And then it tells you the frequency over on the y-axis. There are no spaces in between the bars. Your intervals should always be equal gaps. You shouldn't have one that goes like 1 to 10 and then the next one 11 to 30. They need to be the same gap basically in each. So the histogram, it shows the values within the intervals, but it won't tell you what the actual values are. So like in this first histogram here, where it's 1 through 20, there's some mystery there. We don't know, maybe there's 9 ones, maybe there's 9 20s, or maybe it's a mixture of numbers somewhere in between there, but there's definitely 9 of them. So there is a little bit of mystery about our data within the histogram. You could change the intervals to see how the data would look different with the different intervals, and they can only be used for numerical data. Now, because we've got the intervals and we just are displaying the frequency within those intervals, it makes it easier to display large data sets with histograms. Histograms are nice to show the shape of the distribution. We'll talk about that on a later slide. You can see where the center of the data is, how spread out it is, and it's also easy to tell if there's any outliers as well. When we talk about the shape of a histogram, we're looking at a general trend. So we would not want to think of it as the thing on the left, rigid lines that go to the tops. But instead, we want to think of it as a nice smooth curve that roughly represents the general trend of the data. The top picture here is symmetric data. So notice if you did a general trend with it, it would be symmetric. We could fold it right down the middle and roughly fold right over on itself. It's a mirror image. If data is skewed, we say that it is skewed based on where the tail would be. So if we did a rough sketch of this data, it would look something like that. Well, notice there's a tail here on the right. So we would say that data is right skewed. Now it's not pictured here, but left skewed would be if we had a tail on the left and then the mound is on the right. So the key thing is you tell how it is skewed by where the tail is. Now, the skew is often occurs if there might be outliers on one side. That's what could create that tail. So there's different shapes that you could have within your distribution. So if you only have one mound, in that top left one, we say that's unimodal, or one mode. Mode means the one that happens most often. If the columns are all roughly the same, they don't have to be exactly the same, but they're all roughly the same, we would say that data is uniform. A normal curve is a symmetric curve, but has certain spread among the data, and we will talk about that much more later in the unit. And you could have other ones that have more than one mode. So this is a multimodal distribution. Notice there's 3 separate mounds in that. Box plots, they separate the data into 4 quartiles. So within each gap here, from the minimum to Q1, Q1 to the median, median to Q3, and Q3 to the maximum, there is 25% of the data falling within each of those gaps. Sometimes this is called a 5-number summary because we would have to know 5 different values to know where to put those. Inside the box would be the middle 50% of the data. Notice the number line down on the bottom here. You always put your box plot above a number line so that you know which data correspond to which on that number line. The number line should be making the same jumps. You shouldn't be like having a jump of 10 and the next tick is a jump of 20 or 50 or something like that. It should be consistent, that number line. Box plots are good for large amounts of data. It allows you to see how the data is spread out. The original data values, though, don't show up in the box plot, so there is some mystery in there as well. And it is good to compare 2 different data sets to see where those different 25% chunks would fall. So this slide, just some summaries for them. Dot plots are better for small data. You can see the gaps and clusters. Box plots, they can tell you the center and how spread out it is and are really good for comparison 2 different types of data. And then histogram often is the most popular. It can show the center, the spread, show any skew that you might have. Whenever you make any type of graph, we always want the graph to be labeled. We want to make sure our scale is clear. And if you're comparing 2 or more data sets, make sure your scale is consistent, because otherwise it would be difficult to see how one relates to the other. All right, so we're going to jump ahead a few slides to this page here. So that is on page 10, I believe. And at this point, this is where we will need our scrap graph paper, which hopefully the sub has passed out to you. Now we're gonna end up doing a box plot, a dot plot, and a histogram for this same data. And so you don't want, like, we're gonna start out with our dot plot. You don't want your dot plot to take up the entire piece of paper. Maybe take the top third or so to do the dot plot, the next third to do the box plot, and so on. So to do our dot plot, first we want to see what's our smallest, what's our largest. It looks like our smallest is this 0 here, and the largest I see is 88. So what we're going to have to do is we're going to have to do a number line. So I'm going to, on my number line, I'm going to put 0 here. And I think if we go by 5s or so, we should be able to make it all fit. So this will be 10, 20, 30. Now I said we're going by 5s, and what confuses people sometimes is notice I'm only labeling every 10, but I'm skipping 2 boxes to do that, so technically each box is going by 5s. We got 40, 50, 60, 70, 80, 90, and that should be enough right there because we're only going up to 88. So all we're doing now is we're just stacking dots at each of these values. So our first one is 10, And I like to cross it out once I've plotted it. Next one is 20. Then we've got 12, 14. Now we've got another 12, so we stack it on top of the previous 12. 27. We're way out here at 88. We've got 2, 7, 30, 2 16s, 32, 25. I didn't leave myself much space, but we got 15 right in between there. 4, 0. We've got another 15, and then 6. So one of the things, probably two things stand out from this dot plot. One is that 88 is a huge outlier. An outlier is far away from the rest of the data in one of the directions, either the high or the low end. That's an outlier on the high end. So the spread of this, we would probably see a right skew because of that outlier that is far to the right. Another thing that maybe stands out from this dot plot is we've got 3 values that are tied for our mode, the one that occurs most often. We've got the 16, the 15, and the 12. And that's it for our dot plot. You'll be creating one of those on the homework tonight. So next we're going to do a box plot. And the first thing we want to do on the box plot is we're actually just going to copy that exact same number line down. So we'll give you a moment to label everything for that. Oops, I started with 5, I meant to do 0. And this number line will help us to space out our boxes when we do them in our box plot. And then once we've done this, we want to go over to our calculator. So if you could have your calculators out. On our calculator, we are going to go to a lists and spreadsheet page. Now, if you're already on a page, just go home and then down on the bottom, select the one that looks like a spreadsheet. We've always got to title our column something. Okay, I'm just going to call it A. And then we've got just a long list of numbers, so we're going to put them all in the first column. So I'm not going to read them as I'm typing them because it might be easier for you to just follow where you are on your sheet. But look right on your sheet. We'll type those all in the first column. And then after you've typed them in, I would suggest to just double check and make sure you didn't make an error typing it in. I've found over the years that about 20% of the time, just because there's so many numbers to type in, people will make an error. So I'll stop talking for a minute and allow you to punch those in. So it looks like there's 19 things total. And again, just double check, make sure you typed them in correctly. So once you've typed them in correctly, move to a blank box. Okay, not one of the gray ones, a blank white one. Now, when you've clicked on that blank box, make sure the cursor's not showing. So if that cursor's showing, we don't want that. So click on the blank box, make sure no cursor's showing. So we're going to go to Menu, Statistics, Stat Calculations, and we want one variable statistics. So again, that was Menu, Statistics, Stat Calculations, one variable statistics. We're always going to have one list, and we need to tell it what our list was called. So whatever you titled that heading, that needs to go here. If you had a second column that told you how many of each of those numbers you had, you would change the frequency list. But for us, if we have one column, you just leave the frequency list as 1. And then you hit OK. And it gives us all this information. We'll learn about what a lot of these things are. But if you scroll down, the ones we care about right now, start with the min and go to the max. So we've got a min of 0. Q1, where the box starts, is 7. The median line, the one that shows you where the exact middle is, if you work in from the high and low ends, is 15. The box will end at 25, and then our max is 88. So write down those 5 numbers, either in your packet or off to the side of your graph page. And we'll go back over to our number line. So I usually like to plot the Q3, or the Q1, the median, and the Q3 first. So our Q1 was at 7. So roughly where 7 is, make a vertical line to start your box. And our box is going to go all the way to Q3, which was at 25. And then our median was at 15. So we'll put a vertical line at, oops, I put that in the wrong spot. Our vertical line at 15, which would be right there. And then we have branches that come out either side to the min and the max. So we would have one go down to 0, and then one would go all the way up to 88. And then the last thing we do is we just label what those 5 values really were. We had 0, 7, 15, 25, and 88. So each of those gaps represents 25% of the data. So the box plot itself doesn't tell us what the individual data values are, just where they're grouped, where each of those 25% are. So that's all that we'll be doing for today's lesson. If there's any time left in the period, you can start working on the day 1 homework. Have a great rest of your day.